what we're looking at here is translating functions. So the one that you were asked to graph first was y equals x squared. And that's this one. Y equals x squared. It's just a parabola, right? You shouldn't have been surprised when you graphed y equals x squared that that's what it looks like. You should be pretty familiar with that function. And then you were asked to graph y equals x squared plus 1. And we're looking at how did that graph compare to y equals x squared. Y equals x squared is the parent function here. Y equals x squared plus 1 is a transformation of that parent function. And how did it change? It translated up 1. And then you're asked to graph this one, which is y equals x squared minus 5. And how did that one change compared to y equals x squared? Translate it down 5. And basically, that's what you need to generalize what's happening there. And that's what we're going to do here. This little part, this is the important stuff. The graph of y equals f of x plus k. So if you take a function, like y equals x squared, or some other function, and you add a value k, that graph will be congruent to the original graph, so to the graph of f of x, which means all of these look like the same size and same shape. It's not, by adding a number, you're not going to change the size or shape of the graph. What is going to change is this. When k is greater than 0, the function is translated up k units. When k is less than 0, the function is translated down k units. So like I said, that's basically the important information. No matter what function you start with, if you add a value to it, if that value is positive, then the graph is going to move up that many units. If that value is negative, then it's going to move down that many units. It doesn't matter what the original function looks like. It actually doesn't even matter if the original thing is a function, but we won't get into that. But that's what's going to happen. And then underneath that, a mapping rule. XY maps to, So we're saying, what happens to the x values when you make a new graph? They stay the same. So I'm going to say x maps to x, which means you take the original x value and you keep it the same. X maps to x. But what about the y value? You add whatever the value of k is, right? So to go from x squared to x squared plus 1, keep all the x values the same, but add 1 to all the y values. To go from x squared to x squared minus 5, keep the x values the same, but add negative 5 to all the y values. So now we should be able to make predictions about graphs with vertical translations. What will the following graph look like? Y equals f of x plus 5. What's that going to look like? It's going to be moved up 5. So it's going to be congruent to whatever f of x is and translate it 5 units up. Doesn't matter what f of x was. It's still going to be congruent to that, so look the same as f of x, but translate it 5 units up. Here's another question that has to do with that mapping rule that we came up with. What will the coordinates of each of the points on f of x be after it's transformed? So f of x has this point 1, 5. What will it look like on f of x plus 5? Where will that point go? So we know the mapping rule is xy maps to x stays the same, and we said y plus k, so this is going to be y plus 5. So all you need to do, this one is going to map to, like Akash said, 1 and 10. 1 stays the same, add 5 to the 5. And the other one, 2 stays the same, add 5, so it's 2. The other one moves to 2, 2. This is the second part. So you started with y equals the absolute value of x, which is this graph up here. And the second one was y equals the absolute value of x plus 2. That's different than the absolute value of x with a 2 added to it. This one we know from before would move up 2 units, right? The second one. But that's not what we did. The 2 is inside the absolute value sign. So it's with the x, not on the entire function. We're adding 2 to the x, not to the entire function. And what happens to the graph? It goes to the left 2. Yeah. And this one was y equals the absolute value of x minus 5. And what happened to that graph? It moves to the right 5. So when the number that you're adding is not added to the function itself, but added to the x value, it moves to the left or right. And we need to figure out when it goes to the right and when it goes to the left. If you see x minus something, which way is it going to move? To the right. If you see x plus something, it's going to move to the left. This part is just a little bit confusing because it says the graph of y equals f of x minus h is congruent to the graph of y equals f of x. That makes sense. When h is greater than 0, the function is translated. Which direction is it translated? So when h is less than 0, that means you're subtracting a negative number, which actually looks like adding a number. The function is translated to the left. When we look at the mapping rule, which value changes now, the x or the y?
X.
The x. And what happens to the x? For the mapping rule. The y is going to stay the same, so I'm going to leave that as a y. But what do we have to do to the x value to get the new graph? Is it minus h or is it plus h? It's x plus h and y for the mapping rule. But what you need to remember when you put that in there, if it says negative 5, you put the opposite in the mapping rule. So you write x plus 5. If it's x plus 2, like in this one on the right, you're going to put that in the mapping rule as x minus 2. So you put the opposite of what it tells you in the equation. Okay, a couple last questions here. Now we should be able to make predictions about graphs with horizontal translations. What will the following graph look like? Y equals f of x plus 4. Yeah, congruent to f of x, but moved 4 units to the left. What will the coordinates of each of the points on f of x be after it's transformed? So what's the mapping rule for this one? The mapping rule first, xy maps to x minus 4 and y. So it says plus 4 up here, it goes to a minus 4 down there. And then we can do that to those points. So 3 minus 4. Try that again. 3 minus 4, so this goes to negative 1, and y stays the same at negative 6. And for the second one, it was 2, 7, so it goes to negative 2 and 7. 2 minus 4 is negative 2, 7 stays the same.